modest contribution to this conference is entitled Chemical Analysis and Evaluation. My modest contribution in this conference is entitled Chemical Analysis and Evaluation of antimicrobial activities of extract from aerial and underground parts of Algerian Echinops spinosus. The work plan is as follows: introduction, bibliography, experiments, results, and discussion, and finally, conclusion and prospects. As an introduction, we can say that Algeria, owing to its extensive land area and biogeographical position, is home to an extraordinary floral and ecological diversity, featuring over 3,000 plant species belonging to numerous botanical families. Among these, approximately 15% are endemic and remain largely unexplored in phytochemical, pharmacological, and biotechnological terms. On the other hand, infections caused by pathogenic microorganisms such as bacteria, fungi, and viruses continue to pose a significant public health challenge. The increasing resistance to conventional antibiotics and antifungal agents underscores the urgent need for the discovery of new sources of antimicrobial substances. In this context, the aim of our study is to valorize Echinops spinosus as plant that is widely distributed in Algeria and frequently used in traditional medicine. This valorization is throughout, first, a chemical analysis of the aerial as stems, leaves, flowers, and underground as roots, rhizomes, parts of Echinops spinosus. In second, to determine the potential as antimicrobial agents of the chemical compounds present in these plants. Echinops spinosus belongs to the Asteraceae family. It's perennial herbaceous plant. Its height varies between 40 and 80 centimeters. It has very thorny, branched, reddish-brown stem. Its leaves are over and deeply lobed, 5 to 15 centimeters. Its flowers are in form of spherical capitula, 4 to 6 centimeters in diameter, dotted with shades of blue, and contain hermaphrodite flowers. In Arabic, this plant is called Fuga al-Jmal, Shuk al-Jmal, Ikshir, or Skor. Bibliography has demonstrated the abundance of secondary metabolites in various Echinops spinosus organs belonging to different classes such as phenolic compounds, flavonoids, glycosylated compounds, alkaloid, sesquiterpene, and polyacetylene thiophene. Several species of the Echinops genus are traditionally used for their medicinal properties, particularly in Africa. These plants are widely used in the treatment of various diseases, as stimulate the nervous system, act as venous vasoconstrictor, fight digestive disorders, abdominal and stomach pain, used for fighting urinary tract infections, treatment of hemorrhoidal diseases, treating oral and vaginal candidiasis, helps improve blood circulation. Well, bibliography has, no, it's not here. For the experiment, the plan is material extraction, chemical screening, and antimicrobial activity. For the blunt material, our study was based on the two parts. aerial and underground of Echinops spinosus. Harvesting took place in May 2022 in the Hajab region of the Biskra Wilaya in the southern of Algeria. The samples were carefully harvested, rinsed, and dried in an airy, shady, and dry place. To test antimicrobial activity, we assessed 5 bacterial strains, gram-positive and gram-negative, and 2 fungal strains, which are listed below. Staphylococcus aureus, Bacillus subtilis, Pseudomonas aeruginosa, Escherichia coli, Salmonella abuni, Candida albicans, and Aspergillus niger. Extracts were prepared by 2 different methods, Soxhlet extraction and hot extraction by maceration. The extraction yield was calculated according to the following equation: M0 divided by M1 multiplied by 100, which M0 is a weight in grams of evaporated residue, and M1 is a weight of initial dry plant material. The chemical screening represents all qualitative techniques for determining the presence or absence of secondary metabolites. The principle of screening is based on solubility, coloration, and precipitation tests. These tests are performed on Soxhlet extract and obtained by maceration of the 2 plant parts. Tested chemical groups are quinones, alkaloids, coumarins, saponosids, tannins, polyphenols, flavonoids, and reducing sugar. To assess antimicrobial activity of the 2 plant parts, we use extracts prepared using different solvents such as chloroformic, etheropetrolic, methanolic, and ethanolic extract. This activity was studied using the agar diffusion method, following the step below. First, preparation of culture media, pouring agar into petri dishes, dilution of extract in DMSO, preparation of microbial suspensions, inoculation of culture media, disc deposit, and incubation of petri dishes. For the yield results of the different extract, we note that the best yield is that of the chloroformic extract obtained by the maceration method, which is 65.9%, and the lowest yield is that of the ethanolic extract obtained by Soxhlet, which is 1.7%. The result of the chemical test done on the aqueous extract obtained by Soxhlet and by maceration of the 2 parts of our plant are presented in this table. We can see that the aqueous extract obtained by Soxhlet from both parts of the plant is positive. For alkaloid, quinones, coumarins, saponosid, tannins, polyphenols, flavonoids, and reducing sugar. We can also see that the presence of the alkaloids more marked in the aerial than in the underground parts. There is a moderated presence of quinones and coumarins in the extract of the aerial part, with a weak reaction in the extract of underground parts. For tannins, polyphenol, and flavonoids, both parts of the plants contain this metabolite with more in the extract of the aerial part obtained by Soxley than obtained by maceration. Generally, we find that the Soxley extraction reveals more secondary metabolite than maceration extract. This slide shows the results of chemical screening of aqueous extract from aerial and underground parts obtained by Soxley, where each test is photographed in the presence of a control. This slide, this one, shows the pictures of the results from the chemical screening of aqueous extract from aerial and underground parts obtained throughout maceration. To evaluate the antimicrobial activity of our Echinops spinosus extract, we use the agar diffusion method, a technique based on measuring the diameter of current inhibition zones around this loaded with plant extract. After 24 hours incubation at 37 degrees for bacteria and 48 hours at 30 degrees, the results for each extract are shown in the following graphs. To interpret the results, we use the standards stated by Moreira and al., which say that 0 is no zone of inhibition, diameter under 8 millimeter is resistant, diameter between 9 and 14 millimeter is sensitive, diameter between 15 and 19 is very sensitive, and diameter over 6 millimeter is extremely sensitive. We can see from these histograms that for the methanolic extract by Soxley, that zones of inhibition range from 8 to 18 millimeters for the bacterial strain tested, and 12 to 32 millimeters for the fungal strains. All bacterial strains are resistant at a concentration of 50 milligrams per milliliter, except for P. aeruginosa, which is sensitive at all concentration tested. S. aureus is resistant to 100 milligrams per milliliter and sensitive to 150 milligrams per milliliter. B. subtilis, Escherichia coli, and S. aboni are sensitive to 100 and 150 milligrams per milliliter. Candida albicans showed resistance to methanolic extract except at 150 milligrams per milliliter. Aspergillus niger induced resistance only at 150 milligrams per milliliter. Ethanolic extract by Soxley showed no effect on all bacterial and fungal strains. For the chloroform extract obtained by Soxley, we note that inhibition diameters vary between 8 and 15 millimeters for bacterial strain and 15 to 20 millimeters for fungal strains. At 50 milligrams per milliliter, all bacterial strains are resistant, as is the fungal strain Candida albicans. At opposite, Aspergillus niger proved highly sensitive at all 3 concentrations tested. P. aeruginosa and S. aboni are resistant to 50 and 100 milligrams per milliliter and sensitive to 150 milligrams per milliliter. B. subtilis and E. coli are sensitive to 100 and 150 milligrams per milliliter. S. aureus is sensitive to 100 milligrams per milliliter and highly sensitive to 150 milligrams per milliliter. Candida albicans was resistant to all three concentrations of our extract, while Aspergillus niger proved highly sensitive. The best result concerns the chloroform extract of aerial parts obtained by maceration, which showed, first, zones of inhibitions ranging from 15 to 50 millimeter for bacterial strain and 20 to 25 millimeter for fungal strain. For most of the strain tested, these inhibition zones exceeded those recorded for the reference drugs as gentamicin 10 and iconazole 1%. No bacterial and no fungal strains are resistant, but almost all are extremely sensitive. But the chloroform extract of the fungal strains but the chloroform extract of the underground part obtained by maceration had no notable effect on all bacterial and fungal strains. As a discussion, we can say that the qualitative chemical strain carried out on the aqueous extract of Echinops spinosus revealed, according to the work of Zabata et al. 2018, the presence of alkaloid, tannins, flavonoid, quinones, reducing sugars. In addition to this metabolite, our study revealed the presence of polyphenol, coumarins, and saponoses. All works consulted on the antimicrobial activity of Echinops spinosus report the use of several types of extract as hexanolic, methanolic, ethanolic, etc. However, to our knowledge, no study has tested the chloroformic extract. According to our results, the chloroform extract of the aerial part obtained by maceration gave considerable antimicrobial activity compared to other extracts obtained by Soxley and compared to the chloroform extract of the underground parts. Significant antimicrobial effects have been reported by Swillam et al. 2022, testing a hexane extract of Echinops spinosus against B. subtilis, B. aeruginosa, Escherichia coli, and Candida albicans. Also, Refour and al. 2019 noted interesting antifungal effects against Candida albicans. However, the study of Zitonin and al. 2022 showed no 2022 showed no antibacterial activity of Echinops spinosus methanolic extract against S. aureus, whereas the methanolic extract of our present study showed moderate antibacterial effects, particularly against this bacterium at concentration of 100 and 150 milligrams per milliliter. This means that the extraction methods and the different concentrations have a significant influence on antimicrobial activity. This results These results showed that the Algerian Echinops spinosus is rich in secondary metabolites. The chloroformic extract obtained by maceration of the aerial parts has good microbial activity. Our results show that the aerial part of this plant performs better than the underground part. As the results obtained in this study show that the aerial chloroformic extract of Algerian Echinops spinosus may be new potential source of antimicrobial agent for the food industry, mainly as natural preservatives to extend the shelf life of food products and as antimicrobial agents to reduce the risk of contamination by pathogens. And also for the pharmaceutical industry by developing potential new antibiotics in the face of growing antibiotic resistance, developing treatment for fungal infection, fewer side effects. As prospects, it would be wise to isolate the specific secondary metabolite that is really responsible for the antimicrobial activity revealed in our extract. However, further studies are needed to obtain more information on the safety and toxicity of this extract to ensure safe and effective use of the extract. This is a bibliographic reference